All right, let's see if we can't wrap up our discussion of the basic 6 trig functions and their graphs with cosecant. This is going to follow very similar to the path that we followed with secant, and also we're going to use our information from cotangent. So cosecant is the same as 1 over sine. So the vertical asymptotes for cosecant are wherever its denominator has a node. The nodes of sine, remember what the sine curve looks like, right? The sine curve has nodes at the integer multiples of pi. So at negative pi, at 0, at 2 pi, at 3 pi. So here's pi over 2, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, and so on. I have negative pi over 2, negative pi, negative 3 pi over 2, 2 pi, and so on that direction. Anywhere sine has a node, that's at 0. So at 0, there is a vertical asymptote. At pi, at 2 pi, at 3 pi, and so on. At negative pi, at negative 2 pi. So anywhere sine crosses the x-axis, anywhere sine has a node, the nodes of the sine curve are the same as the vertical asymptotes for the associated cosecant curve. And then, just like we did with secant and cosine, I'm going to sketch in, just with a dotted line, the graph of the sine curve. Sorry, that's not right. There we go. And so now what do we have? Remember that at the peaks, that's where they coincide. The reciprocal of 1 is 1. So at pi over 2, sine is 1. So the reciprocal is still 1. And so we have the similar structure in that direction. And the similar structure here. Again, we have these, what a former student once called the collection of horseshoes, in both directions. Notice the vertical asymptotes are not in the same place with cosecant as they are with secant. With secant, the vertical asymptotes are where cosine has a node, odd multiples of pi over 2. With cosecant, the vertical asymptotes are where sine has a node, the integer multiples of pi, 0, pi, 2 pi, and so on. Now, there are similarities to the graph. It's not very hard to see that the range of cosecant and the range of secant agree. It's not very hard to see that the period and the standard interval are the same because it inherits those pieces from the sine curve, just as secant inherited it from cosine. So let's go ahead and put the standard information here. So we have domain. The domain is all the real numbers, but what do we throw away this time? Not the odd multiples of pi over 2, all the integer multiples of pi. All the integer multiples of pi. Integer multiples of pi. Anyone who knows what you're doing knows this means the integer multiples of pi. Strictly speaking, you would specify the values for k. It's called an index. But for our purposes, it suffices to say the domain is all the real numbers, subtract off the set containing k pi. These are the integer multiples of pi. The range, it's not hard to see the range is the same for cosecant as it was for secant. So the range is from negative infinity to negative 1. And this time I'll just write a comma, whichever you like. Comma, union, the word or, whichever is fine. Just, leave it nothing. Just put the two pieces. That's fine by me. 1 to infinity. Strictly speaking, I got too much mathematician in me. Strictly speaking, you should have a little union symbol, but that's all right. domain, range. We have the, what's next? The period. The period is the distance required for the curve to repeat itself. That distance is 2 pi, the minimum distance required. It inherits that property from sine. And then the standard interval the standard interval is the same. It inherits that from the sine curve as well. 0 to 2 pi. So the domain, the range, the period, the standard interval. So with that information, you should be very familiar now with the 6 basic functions. You should be able to reproduce any of this information for the basic functions, any one of the 6 basic trigonometry functions. Next up, we'll do or talk about what happens if you do a horizontal shift, what happens if you do a change of amplitude, and so on with cosecant or with secant.